User Interface Components with Swing. In this chapter, we will discuss the following topics: Swing and the Model View Controller Design Pattern. Design Patterns. The Model View Controller Pattern. A Model View Controller Analysis of Swing Buttons. Introduction to Layout Management. Border Layout and Grid Layout. Text Input. Text Fields. Labels and Labeling Components. Password Fields. Text Areas. Scroll Pane. Choice Components. Checkbox. Radio Button. Borders. Combo Boxes. And Sliders. Menu. Menu Building. Icons in menu items. Checkbox and radio button menu items. Pop-up menus. Keyboard mnemonics and accelerators. Enabling and disabling menu items. Toolbars and tooltips. Sophisticated layout management. The Gridback layout. Group layout. Using no layout manager. Custom layout managers and Traversal Order. Dialog boxes. Option dialogs. Creating dialogs. Data exchange. File dialogs and color choosers. The Model View Controller Design Pattern. Design patterns. Past experience would be a source of inspiration to solve a present problem, or you may depend on experts for advice on what has guided them. Design patterns are a method for presenting this expertise in a structured way. The Model View Controller pattern is not the only pattern used in the design of AWT and Swing. Here are several additional examples. Containers and components are examples of the composite pattern. The scroll pane is a decorator. Layout managers follow the strategy pattern. One important aspect of design patterns is that they become part of the culture. Patterns become an efficient way of talking about design problems. Every component has three characteristics: its content, such as the state of a button, pushed in or not, or the text in a text field, its visual appearance, color, size, and so on, its behavior, reaction to events. The MVC pattern accomplishes the following principles of object-oriented design. Don't make one object responsible for too much. Don't execute everything by a single button class. Have the look and feel of the component associated with one object and store the content in another object. Implement three separate classes: the model, which stores the content; the view, which displays the content; the controller, which handles user input. The pattern specifies precisely how these three objects interact. The Model View Controller pattern. The model stores the content and has no user interface. The model must implement methods to change the content and to explore what the content is. The controller handles the user input events such as mouse click and keystrokes. It then decides whether to translate these events into changes in the model or the view. A model can have multiple views. Each shows a different part or aspect of the full content. This figure shows the interactions among model, view, and controller objects. In Swing, each user interface component has a wrapper class such as JButton or JTextField that stores the model and the view. When you inquire about the content, that is the text in a text field, the wrapper class puts forth the model and returns the answer to you. When you need to change the view, the wrapper class forwards a request to the view. The Model View Controller pattern is attractive for the Swing designers because it allows them to implement pluggable look and feel implementations. The model of a button or text field is independent of the look and feel, but the visual representation is completely dependent on the user interface design of a particular look and feel. The controller can vary as well. Patterns are only intended as guidance, not as religion. No pattern is applicable in all situations. A model view controller analysis of swing buttons. Interface is called button model. Since most components, the model class implements an interface whose name ends in model. Classes implementing that interface can define the state of the various kinds of buttons. The swing library contains a single class called default button model that implements this interface. Each JButton object stores a button model object which you can retrieve. JButton button equal to new JButton of blue. Button model equal to button dot get model of. There is no way to find out what's on the face of a button just by looking at its model, since the model does not store the button label or icon. The same model, namely default button model, is used for push button, radio buttons, checkbox, and even menu items, but they have different views and controllers. Each swing component has an associated view object that ends in user interface. Introduction to Layout Management. A Java-enabled development environment will have a layout tool that automates the task of arranging components inside a frame. Components are placed inside containers, and a layout manager determines the position and size of the components in the container. Buttons, text fields, and other user interface elements extend the class component. Components can be placed inside containers such as panels. Extension of component deals with containers placing themselves inside other containers. Example, the button are contained in a JPanel object and are managed by the Flow Layout Manager, the default layout manager for a panel. Figure shows what happens when you add more buttons to the panel. A new row is started when there is no more room. The buttons stay centered in the panel even when the user resizes the frame. Inheritance hierarchy for the component class. Though each container has a default layout manager, you can always set your own. For example, the following statement uses the grid layout class to layout the components in the panel. Panel.setLayout of new grid layout of 4,4. When you add components to the container, the add method of the container licenses the component and any placement directions to the layout manager. Java.awt.container 1.0 void set layout of layout manager m. It sets the layout manager for this container. Component add of component C. Component add of component C, object constraints. It adds a component to this container and returns the component reference. Java.awt.flowLayout 1.0 Flow layout of integer align. Flow layout of integer align integer h gap, integer v gap. It constructs a new flow layout. Border layout. Border layout manager is the default layout manager of the content pane of every JFrame. The border layout manager lets you choose where you want to place each component. For example, frame.add of component, border layout.south. After the edge components are laid out, the remaining available space is occupied by center. When the container is resized, the dimensions of the edge component remains unchanged, but the center component changes its size. Add components by specifying a constant. Center, north, south, east or west of the border layout class. The border layout grows all components to fill the available space. This is a problem when you add a button, since it would fill the entire southern region of the frame. Frame.add of yellow button, border layout.south. Use panels to overcome this problem as JPanel panel equal to new JPanel of panel.add of yellow button, panel.add of blue button, panel.add of red button, frame.add of panel, border layout.south. The output as shown below. Grid layout. The grid layout arranges all components in rows and columns like a spreadsheet. All components are given the same size. In the constructor of the grid layout object, you specify how many rows and columns you need. panel.setLayout of new space grid layout of 4, 4. Add the components, starting with the first entry in the first row, then the second entry in the first row, and so on. Panel.add of new J button of 1. Panel.add of new J button of 2. The calculator program in figure uses a grid layout to arrange the calculator buttons. When you resize the window, the buttons grow and shrink, but all buttons have identical sizes. Java.awt.gridlayout 1.0. Grid layout of integer rows, integer column. Grid layout of integer rows, integer column, integer h gap, integer v gap. It constructs a new grid layout. One of rows and columns, but not both, may be 0, denoting an arbitrary number of components per row or column. Use the JText field and JTextArea components for text input. A text field can accept only one line of text. A text area can accept multiple lines of text. A JPassword field accepts one line of text without displaying the content. All these classes inherit from a class called JText component. The methods that get or set the text in a text field or text area are actually in JText component. javax.swing.text.jtext component. String get text of. Void set text of string text. Gets or sets the text of this text component. Boolean is editable. Void set editable of boolean b. Gets or sets the editable property that determines whether the user can edit the content of this text component. Text fields. The usual way to add a text field to a window is to add it to a panel or other container. JPanel panel equal to new JPanel of. JText field text field equal to new JText field of default input, 20. Panel.add of text field. This code improves a text field and prepares it by placing the string default input inside it. The second parameter of this constructor sets the width. If you expect the inputs to be n character or less, you are supposed to specify n as the column width. The number of columns is only an indication to the AWT that gives the desirable size. The layout manager needs either to grow or shrink the text field. It can automatically adapt its size. The column width that you set in the JText field constructor is not an excessive limit on the number of characters the user can enter. In spite of typing in a longer strings, the input scrolls when the text exceeds the length of the field. To reset the number of columns at runtime, you can do that with the setColumns method. Textfield.setColumns of 10. Panel.revalidate of. To make a blank text field, just leave out the string as a parameter for the JText field constructor. JText field text field equal to new JText field of 20. Change the content of the text field at any time by using the setText method. Textfield.setText of hello. To trim any extraneous leading and trailing spaces from the data in a text field, apply the trim method to the return value of getText. String text equal to textfield.getText.trimOff. To change the font in which the user text appears, use the setFont method. Labels and labeling components. Labels are components that hold text. They have no decorations, for example, no boundaries. They also do not react to user input. Labels can be used to identify components. To label a component which does not come with an identifier, construct a JLabel component with the correct text. Place it closely to the component you want to identify so that the user can see that the label identifies the correct component. The constructor for a JLabel lets you specify the initial text or icon and optionally the alignment of the content. Specify a right-aligned label either as JLabel label equal to new JLabel of username swing constants dot right or JLabel label equal to new JLabel of username JLabel.write. The setText and setIcon methods lets you set the text and icon of the label at runtime. Labels can be positioned inside a container like any other component. Password fields. Password fields are a special kind of text field. Restricting nosy bystanders from seeing your password needs the characters that the user enters are represented by an echo character, typically an asterisk. Swing supplies a JPassword field class that implements such a text field. Is another example of the power of the model view controller architecture pattern. It has the same model to store the data as a regular text field, but its view have been changed to display all characters as echo characters. javax.swing.jPassword field. JPassword field of string text, integer column. Construct a new password field. Void set echo character echo. Sets the echo character for this password field. A value of 0 resets the echo character to the default. Character array get password of. Returns the text contained in this password field. Text areas. You can use the JTextArea component to collect user input that is more than one line long. When you place a text area component in your program, a user can enter any number of lines of text using the enter key to separate them. Each line ends with a /n. In the constructor for the JTextArea component, specify the number of rows and columns for the text area. For example, text area equal to new JTextArea of 8,40. 8 lines of 40 columns each. You can also use the setColumn method to change the number of columns and setRows method to change the number of rows. Scroll pane. If you want scroll bars in a text area, you have to place the text area inside a scroll pane. Text area equal to new JTextArea of 8,40. JScroll pane equal to new JScroll pane of text area. The scroll pane now manages the view of the text area. Scroll bars automatically appear if there is more text than the text area can display, and they vanish again if text is deleted and the remaining text fits inside the area. Checkbox. If you want to collect just a yes or no input, use a checkbox component. Checkboxes automatically come with labels that identify them. The user can check the box by clicking inside it and turn off the checkmark by clicking inside the box again. Pressing the space bar while the focus is in the checkbox also toggles the checkmark. Give the label text in the constructor. Bold equal to new JCheckbox of bold. Use the setSelected method to turn a checkbox on or off. Bold.setSelected of true. The isSelect method then retrieves the current state of each checkbox. It is false if unchecked, then it is true if checked. When the user clicks on a checkbox, this triggers an action event. You attach an action listener to the checkbox. Action listener bold.add action listener of listener. Italic.add action listener of listener. Radio buttons. Most situations we ask the user to check only one of several boxes. When another box is checked, the previous box is automatically unchecked. Such a group of boxes is often called a radio button group. When you push in one button, the previously depressed button pops out. To implement radio buttons, you construct one object of type button group for every group of buttons and add objects of type JRadioButton to the button group. When a new button is clicked, the button group object is responsible for turning off the previously set button when a new button is clicked. The button group controls only the behavior of the buttons. Grouping the buttons for layout purposes needs to be added them to a container such as JPanel. Button group equal to new button group of JRadioButton small button equal to new JRadioButton of small, false. Group.add of small button. J radio button medium button equal to new J radio button of medium comma true. Group.add of medium button. When the user checks a radio button, the button generates an action event. Choice components. Borders. You wish to visually indicate which buttons are grouped among multiple groups of radio buttons in a window. Swing provides a set of useful borders for this purpose. You can apply a border to any component that extends J component. Steps to implement borders. Call a static method of the border factory to create a border. You can choose among the following styles: lower bevel, raised bevel, etched line, matte, and empty. Add a title to your border by passing your border to border factory dot create title border. Combine several borders with a call to border factory dot create compound border. Add the resulting border to your component by calling the setBorder method of the JComponent class. Border edge equal to border factory dot create edge border. Border title equal to border factory dot create title border of h comma a title. Panel dot set border of title. Combo boxes. Radio buttons are not a good choice for many alternatives because they occupy too much screen space. Instead, you can use a combo box. When the user clicks on this component, a list of choices drops down and the user can then select one of them. If the drop-down list box is set to be editable, then you can edit the current selection as if it were a text field. The JComboBox class provides a combo box component. The JComboBox class is a generic class. Call the setEditable method to make the combo box editable. Obtain the current selection by calling the getSelectedItem method. To add a string to the end of the list, JComboBox string face combo equal to new JComboBox of face combo dot add item of serif, face combo dot add item of sans serif. You can add new items anywhere in the list with the insert item at method. Face combo dot insert item at of monospace, 0. To remove items, face combo dot remove item of monospace. Face combo dot remove item at of 0. The remove all items method removes all items at once. Sliders. Sliders offer a choice from a continuum of values. For example, any number between 1 and 100. The most common way of constructing a slider is given below. JSlider slider equal to new JSlider of min, max, initial value. If you want the slider to be vertical, use the following constructor call. JSlider slider equal to new JSlider of swing constants dot vertical, min, max, initial value. As the user slides a slider bar, the value of the slider moves between the minimum and maximum values. When the value changes, a change event is sent to all change listeners. Call the addChangeListener method to be noted on the change and install an object that implements the ChangeListener interface that has a single method stateChange. Public void stateChange of change event open bracket. JSlider slider equal to JSlider event dot get source of integer value equal to slider dot get value of bracket closed. Swing also supports another type of user interface element, the pull-down menus that are familiar from GUI applications. A menu bar at the top of a window contains the names of the pull-down menus. Clicking on a name opens the menu containing menu items and submenus. When the user clicks on a menu item, all menus are closed and a message is sent to the program. Menus. Menu building. Building menus is certainly straightforward. Creating a menu bar. menu bar equal to new menu bar of frame.setJMenuBar of menu bar. For each menu, you create a menu object. JMenu edit menu equal to new JMenu of edit. Add the top level menus to the menu bar. Menu bar dot add of edit menu. Add menu item, separators and submenus to the menu object. JMenu item paste item equal to new JMenu item of paste. Edit menu dot add of paste item. Edit menu dot add separator. JMenu options menu equal a submenu. Edit menu dot add of options menu. When the user selects a menu, an action event is triggered. You need to install an action listener for each menu item. Action listener equal to paste item dot add action listener of listener. The add method returns the created menu item. You can capture it and then add the listener as follows. JMenu item paste item equal to edit menu dot add of paste. Paste item dot add action listener of listener. For example, action exit action equal to new abstract action of exit open bracket public void action perform of action event open bracket action code goes here system dot exit of 0 bracket close. You can then add the action to the menu. JMenu item exit item equal to file menu dot add of exit action. Icons in menu items. Menu items are very similar to buttons. Just like buttons, menus can have just a text label, just an icon, or both respectively. You can specify the icon either with the JMenu item of string comma icon or JMenu item of icon constructor, or you can set it with the setIcon method that the JMenu item class inherits from the abstract button class. JMenu item cut item equal to new JMenu item of cut comma new image icon of cut.gif. By default, the menu item text is placed to the right of the icon. Place the text on the left. Call the set horizontal text position method that the JMenu item class inherits from the abstract button class. Cut item dot set horizontal text position of string constants dot left. To add an icon to an action, cut action dot put value of action dot small underscore icon comma new image icon of cut.gif. To set the icon in the abstract action constructor, cut action equal to new abstract action of cut comma new image icon of cut.gif open bracket public void action perform action event open bracket action code goes here bracket closed. Checkbox and radio button menu items. Checkbox and radio button menu items pageant a checkbox or radio button next to the name. When the user selects the menu item, the item automatically toggles between checked and unchecked. To create a checkbox menu item, JCheckbox menu item read only item equal to new JCheckbox menu item of read only. Options menu dot add of read only item. Automatic deselection of radio button is resulted when one of the radio button is selected. Button group equal to new button group of J radio button menu item insert item equal to new J radio button menu item of insert. Insert item dot set selected of true. J radio button menu item overtype item equal to new J radio button menu item of overtype. Group dot add of insert item. Group dot add of overtype item. Options menu dot add of insert item. Options menu dot add of overtype item. Use the isSelected method to test the current state of the menu item. Pop-up menus. A pop-up menu is a menu that is not attached to a menu bar but floats somewhere. Create a pop-up menu just as you create a regular menu, except that a pop-up menu has no title. J pop-up menu pop-up equal to new J pop-up menu of. Add your menu items as usual. J menu item equal to new J menu item of cut. Item dot add action listener of listener. Pop-up dot add of item. You must explicitly display a pop-up menu by using the show method. Specify the parent component and the location of the pop-up using the coordinate system of the parent. Popup.show of panel, x, y. To pop up a menu when the user clicks on a component using the pop-up trigger, simply call the method component.setComponent popup menu of popup. Keyboard mnemonics and accelerators. It is a real convenience for the experienced user to select menu items by keyboard mnemonics. You can create a keyboard mnemonic for a menu item by specifying a mnemonic letter in the menu item constructor. J menu item about item equal to new J menu item of about A. The keyboard mnemonic is displayed automatically in the menu with the mnemonic letter underlined. For example, the items of the last example, the label will be displayed as about with an underlined letter A. When the menu is displayed, the user just needs to press the A key and the menu item is selected. You can specify which character you want to have an underline by calling setDisplayed mnemonic index method. To attach a mnemonic to a menu, call the setMnemonic method. JMenu help menu equal to new JMenu of help menu dot set mnemonic of H. Accelerators are keyboard shortcuts that let you select menu items without even opening a menu. Use the setAccelerator method to attach an accelerator key to a menu item. The setAccelerator method takes an object of type keystroke. For example, the following call attaches the accelerator Ctrl+O to open item menu item. Open item dot set accelerator of keystroke dot get keystroke of Ctrl+O. Accelerator keys directly fire the action event associated with the menu. Enabling and disabling menu items. Occasionally, a particular menu item should be selected only in certain context. It is better to deactivate the menu items that lead to temporarily inappropriate commands. A deactivated menu item is shown in gray, hence it cannot be selected. To enable or disable a menu item, use the setEnable method. Save item.setEnable of false. The javax.swing.event package defines a menu listener interface with three methods. Void menu selected of menu event event. Void menu deselected of menu event event. Void menu cancel of menu event event. The menu selected method is called before the menu is displayed. It can therefore be used to disable or enable menu items. Example, the following code shows how to disable the save and save as actions whenever the read-only checkbox menu item is selected. Public void menu selected of menu event event. Save action dot set enable of read-only item dot is selected. Save as action dot set enable of read-only item dot is selected of bracket closed. Toolbars. A toolbar is a button bar. It gives quick access to the most commonly used commands in a program. You can drag the toolbar to one of the four borders of the frame. When you release the mouse button, toolbar is dropped into the new location. The toolbar can even be completely detached from the frame. A detached toolbar is delimited in its own frame. When you close the frame, having a detached toolbar, the toolbar jumps back into the original frame. To add components into the toolbar, JToolbar bar equal to new JToolbar of bar.add of blue button. To populate the toolbar with action objects, bar.add of blue action. You can separate groups of buttons with a separator, bar.add separator of. To have a toolbar start out vertical, use bar equal to new JToolbar of swing constants dot vertical. Tooltips. A disadvantage of toolbars is that users are often mystified by the meanings of the tiny icons in toolbars. To solve this problem, user interface designers invented tooltips. A tooltip is activated when the cursor rests for a moment over a button. The tooltip text is displayed inside a colored rectangle. When the user moves the mouse away, the tooltip disappears. You can add tooltips to any J component simply by calling the setTooltipText method. exit button dot set tooltip text of exit. In action objects, you associate the tooltip with a short description key. Exit action dot put value of action dot short description, exit. Sophisticated layout management. Since Java 1.0, the AWT includes the Gridback layout that lays out components in rows and columns. The row and column size are flexible and the components can span multiple rows and columns. In spite of being very flexible, layout manager is very complex. In 2005, the NetBeans team invented the Mattis technology, which combines a layout tool and a layout manager. A user interface designer uses the tool to drop components into a container and to indicate which components should line up. The tool translates the designer's intention into instructions for the group layout manager. This is much more convenient than writing the layout management code by hand. The Gridback layout. The Gridback layout is the pioneer of all layout managers. In a Gridback layout, the rows and columns can have variable sizes. You can join adjacent cells to make room for larger components. The components need not fill the entire cell area, and you can specify their alignment within cells. To describe the layout of the Gridback manager, use the following procedure. Create an object of type Gridback layout. Set this Gridback layout object to be the layout manager for the component. For each component, create an object of type Gridback constraints. Set field values of the Gridback constraints object to specify how the components are laid out within the Gridback. Finally, add each component with its constraints by using the call add of component, constraints. Example: Gridback layout equal to new Gridback layout of panel dot set layout of layout. Gridback constraints equal to new Gridback constraints of constraints dot weight x equal to 100. Constraints dot weight y equal to 100. Constraints dot grid x equal to 0. Constraints dot grid y equal to 2. Constraints dot grid width equal to 2. Constraints dot grid height equal to 1. Panel dot add of component, constraints. The grid x, grid y, grid width and grid height parameters. The grid x, grid y, grid width and grid height constraints define where the component is located in the grid. The grid x and grid y values specify the column and row position of the upper left corner of the component to be added. The grid width and grid height values determine how many columns and rows the component occupies. The grid coordinates start with 0. Grid x equal to 0 and grid y equal to 0 denotes the top left corner. Weight fields. Always need to set the weight fields, weight x and weight y, for each area in a Gridback layout. If you fix the weight as 0, the area never grows or shrinks beyond its initial size in that direction. If you set the weights for all areas as 0, the container will huddle in the center of its allotted area instead of stretching to fill it. The row and column weight are computed as the maxima of the cell weight in each row or column. The fill and anchor parameters. When there is no need for the component to stretch out and fill the entire area, set the fill constraint. The four possibilities for this parameter are Gridback constraints: none, Gridback constraints, horizontal, Gridback constraints, vertical, Gridback constraints, and both. If the component does not fill the entire area, you can specify where in the area you want it by setting the anchor field. The valid values are Gridback constraints: center of the default, Gridback constraints dot north, Gridback constraints dot northeast, Gridback constraints dot east, and so on. Padding. Set the inserts field of Gridback constraints to surround a component with additional blank space. The external padding is termed in such a way while setting the left, top, right and bottom values of the insert object to the amount of space that you want to have around the component. Alternative method to specify the grid X, grid Y, grid width and grid height parameters. Instead of setting the grid X and grid Y values to absolute position, you set them to the constant Gridback constraints dot relative. Add the components to the Gridback layout in a standardized order, going from left to right in the first row, then moving along the next row and so on. Specify the number of rows and columns span by giving the appropriate grid height and grid width fields. If the component continues till the last row or column, you don't need to specify the actual number, but the constant Gridback constraints dot reminder. This tells the layout manager that the component is the last one in its row. Helper class to tame the Gridback constraints. The most tedious aspect of the Gridback layout is writing the code that sets the constraints. We can write helper functions or a small helper class for this purpose. This class has the following features. Its name is short, GBC instead of Gridback constraints. It extends Gridback constraints so you can use shorter names such as gbc.east for the constants. Use a gbc object when adding a component such as add of component new gbc of 1, 2. There are two constructors to set the most common parameters, grid X and grid Y or grid X, grid Y, grid width and grid height. Add of component new gbc of 1, 2, 1, 4. There are convenient setters for the fields that come in X by Y pairs. Add of component new gbc of 1, 2 dot set weight of 100, 100. The setter methods return this, so you can chain them. Add of component new gbc of 1, 2 dot set anchor of gbc dot east dot set weight of 100, 100. The set inserts method construct the inserts object for you. To get one pixel inserts, simply call add of component new gbc of 1, 2 dot set anchor of gbc dot east dot set inserts of 1. Group layout. Points regarding the Mattis GUI Builder in NetBeans. Start a new project and add a new JFrame form. Drag a label until two guidelines appear that separate it from the container borders. Drag a text field so that its baselines lines up with the baseline of the first label. Line up a password field with the label to the left and text field above. Components are systemized by placing them into objects of type group layout dot sequential group or group layout dot parallel group. These classes are subclasses of group layout dot group. The various add methods of the group classes return the group object, so that method calls can be chained like this. Group dot add component of dot add preferred group dot add component of. Using no layout manager. Many times when you have no botheration with layout managers but still just want to drop a component at a fixed location. To place a component at a fixed location, follow the below steps. Set the layout manager to null. Add the component you want to the container. Specify the position and size that you want. Frame.set layout of null. J button OK equal to new J button of OK. Frame.add of OK. OK.set bounds of 10, 10, 30, 15. Custom layout managers. You can project your own layout manager class. That class manages components in a special way. The own layout manager implement the layout manager interface and override the following 5 methods. Void add layout component of string s, component c. Void remove layout component of component c. Dimension preferred layout size of container parent. Dimension minimum layout size of container parent. Void layout container of container parent. Traversal order. When a window is first displayed, the first component in the traversal order has the keyboard focus. Each time the user presses the tab key, the next component gains attention. The traversal order is straightforward, first left to right and then top to bottom. For example, in the font dialog example, the components are traversed in the following: Face combo box, sample text area. Press Ctrl plus Tab to move to the next field. The tab character is considered. Text input, size combo box, bold checkbox, and italic checkbox. Dialog boxes, option dialogs. Swing has a set of ready-made simple dialogs that suffice to ask the user for a single piece of information. The J option pane has 4 static methods to show these simple dialogs. The input dialog has an additional component for user input. This can be a text field into which the user can type an arbitrary string or a combo box from which the user can select one item. The icon on the left side depends on one of 5 message types: error underscore message, information underscore message, warning underscore message, question underscore message, and plain underscore message. It has no icon. For each dialog type, you can specify a message. Here is how the message object is displayed. The buttons at the bottom depend on the dialog type and the option type. When calling show message dialog and show input dialog, you get only a standard set of buttons. When calling show confirm dialog, you can choose among 4 option types: default underscore option, yes underscore no underscore option, yes underscore no underscore cancel underscore option, OK underscore cancel underscore option. The show confirm dialog and show option dialog return integers to indicate which button the user choose. For the confirmation dialog, the return value can be one of the following: OK underscore option, cancel underscore option, yes underscore option, no underscore option, and closed underscore option. Creating dialog. To implement a dialog box, you extend the JDialog class. This is essentially the same process as extending JFrame for the main window for an application. In the constructor of your dialog box, call the constructor of the superclass JDialog. Add the user interface components of the dialog box. Add the event handlers. Set the size for the dialog box. When you call the superclass constructor, you will need to supply the owner frame, the title of the dialog, and the modality. Where the dialog is displayed is controlled by the owner frame. You can supply null as the owner when the dialog is owned by a hidden frame. Data exchange. The most common reason to put up a dialog box is to get information from the user. The dialog box should provide methods to set default data. For example, the password chooser class of the example program has a method setUser to place default values into the next fields. Public void setUser of user u, open bracket, username dot set text of u dot get name of close bracket. Show the dialog by calling set visible of true. The dialog is now displayed. The user then fills in the information and clicks the OK or cancel button. The event handlers for both buttons call set visible of false, which terminates the call to set visible of true. The default button is specially marked, often with a thick outline. Set the default button in the root pane of the dialog. Dialog.getRootPane of .set default button of OK button. File Dialogs. A GFileChooser is provided by Swing class that allows you to display a file dialog box similar to the one that most native applications use. GFileChooser dialogs are always modal. A GFileChooser class is not a subclass of JDialog. Instead of calling setVisibleOfTrue, call showOpenDialog to display dialog for opening a file, or call showSaveDialog to display a dialog for saving a file. The button for accepting a file is then automatically labeled Open or Save. You can also supply your own button label with the showDialog method. Steps to put up a file dialog box and recover what the user chooses from the box. Make a GFileChooser object. Unlike the constructor for the JDialog class, you do not supply the parent component. This allows you to reuse a FileChooser dialog with multiple frames. For example, GFileChooser chooser equal to new GFileChooser of. Set the directory by calling the setCurrentDirectory method. For example, to use the current working directory, chooser.setCurrentDirectory of new file. If you have a default file name to be chosen by the user, supply it with the setSelectedFile method. Chooser.setSelectedFile of new file of file name. To enable the user to select multiple files in the dialog, call the setMultiSelectionEnable method. Chooser.setMultiSelectionEnable of true. If you want to restrict the display of files in the dialog to those of a particular type, you need to set a file filter. By default, a user can select only files with a file chooser. If you want the user to select directories, use the setFileSelectionMode method. Call it with jfilechooser.files_only, the default, jfilechooser.directories_only, or jfilechooser.files_and_directories. Show the dialog box by calling the showOpenDialog or showSaveDialog method. You must supply the parent component in these calls. Integer result equal to chooser.showOpenDialog of parent, or integer result equal to chooser.showSaveDialog of parent. Get the selected file or files with the getSelectedFile method or getSelectedFiles method. These methods return either a single file object or an array of file objects. String file name equal to chooser.getSelectedFile.getPathOf. Color choosers. Swing makes available a chooser, the JColorChooser. Use it to let users pick a color value. Like the GFileChooser class, the ColorChooser is a component, not a dialog, but it contains convenient method to create dialogs that contains a ColorChooser component. To show a model dialog with a ColorChooser, color selected color equal to jColorChooser.showDialog of parent, title, initial color. Alternatively, you can display a modeless ColorChooser dialog. Supply the following: parent component, the title of the dialog, a flag to select either a model or a modeless dialog, a ColorChooser, and the listeners for the OK and cancel.